Okay, so welcome back to another video. So it's actually been a while in this channel since we cover a number theory problem. So what we want to do is we want to find all natural numbers n such that the square root of n plus the square root of n plus 2020 is a natural number. So the idea here is pretty basic. What we want to do is, of course, since this whole expression has to be in terms of a natural number, we'll let some constant be that natural number, then solve using some, typical algebra manipulations and all that stuff. Then it actually comes down to the general concept that we have to apply some factorization with a certain number such that it actually deems the sufficient conditions we need to find what n is, such that it also at the same time has to be a natural number. So there's actually a step specifically after doing the algebra where you can actually just compute this by brute force. It's really just the easy method, but I'm actually going to do a little bit of some explanation that actually will save you a lot of time. So you can choose however method you want to solve either way. So why don't we actually just jump right in. So square root of n and then plus the square root of n plus 2020, we'll set that equal to be a, for a is a natural number. Of course, that expression is what we're trying to solve for the natural number n. So applying some typical algebra techniques, we'll let the square root of n plus 2020, and we'll subtract the square root of n to both sides. So I have a subtract the square root of n. Then what we can do here is let's actually take the square of both sides. So that means that'll just get rid of the radical. So in other words, I have n plus 2020, then set this equal to a minus the square root of n quantity square. Then if you actually expand that out, I have a square, and then subtract with 2 times a times the square root of n, and then add this with just n. And what you'll notice is that if I just continue forward with canceling some terms out, n's are gonna cancel over here. So what we're left with is just a square, then minus 2 times a times the square root of n. Then just set this equal to 2020. And then, of course, we still have a and an n. So the whole point is that we want to solve for n. Since we're actually trying to find that natural number n we're trying to, achieve such that the expression is a natural number. So what we'll do is let me actually subtract an a squared to both sides. So I have negative 2a, then times the square root of n. Set this equal to 2020, then subtract a square. Let's divide the negative 2a to both sides. And so now what this yields is that, so that just leaves us with just the square root of n, then set this equal to, so I have that the a's will cancel, and let me actually rearrange the terms such that this is actually just the leading term. So what we have now, this is going to be a divided by 2, and then subtract with 2020 divided by 2a. Now, of course, I can reduce this down if I want to, since it is, 2020 is divisible by 2, but we want it in a certain fashion just so we can actually take a look at some observations for when the factorization step applies. So with that, let me actually just factor out the 1/2 from everything here. So square root of n is then equal to 1/2. And then now let's multiply by, so that's 1/2 I already factor out. So I have a, and then subtract 2020 divided by a. And now we just take the square both sides. So now I have just n is simply just equal to 1/4. And then now multiply with a minus 2020 and then divided by a, all this being quantity square. So now we have n that we can actually solve for, but then we also have this a that has to actually be in the set of the expression over here in order to be a natural number as well. So where do we go forward from here? Our biggest obstacle that we want to solve for? Well, you'll notice is that specifically for n has to be a natural number, some conditions need to be satisfied for our constant a. For one, it has to be a factor of 2020, and it also has to give out in the term of a square that is also divisible by 2, such that once you manipulate this, the 4's will actually just cancel out. So let me actually list out our factors of 2020. So what we notice is that if I factor out 2020, we actually get 12 different factors. So let me actually write down our factors of 2020, and then let me just list out in terms of the multiplication. So I have 1 times 2020, we have 2 times 1010, 1010. Another one we have is 4 times 505. Next we have is that we have a factor of 5 times 404. Another one is 10 times 202. And then we have 20 then times 101. So we have 12 different factors, and then the multiplications over here. So now, of course, as mentioned, you can actually take the simple step and actually just calculate each of these factors, plug this back in to get the n as you want, and then you'll see which of the numbers such that n is a natural number for for a, it also has to be a natural number of that expression. So that'll take you a while. You could use whatever device you want, but let's say this was a competition, you weren't allowed a certain device. So what is the observation we actually have to pay attention to? You'll notice that specifically for our odd and even pairs of the factors, they actually can be ignored simply because that it's actually not divisible by 4. You're actually going to get something of a rational number, which of course that's not allowed in our world of the numbers we're looking at. Natural numbers specifically, we are taking our primary focus on. So with that being the case, we actually have 6 factors we can actually ignore. So what we can ignore is, as I mentioned, the odd and the even factors. So we can actually get rid of the 1 times 2020. The other one we can ignore is 5 times 404. I think I said 3 by mistake, but 4 different multiplication. So 8 factors we can ignore. That's what I meant to say. Another one we can ignore is 4 times 505. And then the last one we can ignore is 20 times 101. So with that being the case, that means A can be simply these following numbers. A can equal 2, 10, 202, and then 1010. So we actually have these 4 numbers we can actually plug in. So what the thing is that it doesn't matter which of the order factors you plug in, because if I plug in this or this, the numbers are actually going to yield out exactly the same as it is. Same thing for this one too, 10 times 202. Either you plug 10 for A or 202 for A, which no matter of the pair that you actually, that is associated with, it's actually going to yield out the same number. So let me actually just use the bigger number for that sake of that. So A is equal 202 or A is equal 1010. So if I plug in A is equal to 2, so if I plug this in, that means I have now, this is going to be 1 divided by 4, then multiply with 202, then minus 2020 divided by 202, which that's a factor of, so that's actually going to be 10. And so what that means is that 202 minus 10, that's actually going to yield us with 192. That can actually be breaking down to say this is 1 over 4 multiplied by, that's a square over here, don't forget about that, 2 times 96 quantity square. And if I actually just, apply with the distribution for the multiplication, so 2 square and then times 96 square, 2 square is 4, 4 will cancel. So that means that n is going to equal 96 square. Then if you actually do the multiplication, we get that we have that n is going to equal to 9,216. Okay, so that's actually one number for n that can actually satisfy that following. And then the last one, so 1010, if I do the same thing, so 1 divided by 4 multiplied by 1010, and then minus 2020 divided by 1010, which is actually just going to equal 2. And then that's completely written as 1 divided by 4 multiplied by, so 108. And if I actually, break that up to say this is 2 times 504 quantity square. I keep forgetting the square on this one. So again, same thing, distribution, 2 square, that's 4. Let's get rid of that. So that means n is equal to 504 square. And then it's going to be a big number if you do, simply expand this out. That n is actually just going to equal to 254,016. And so therefore, we actually have our n values. We have that n for the natural numbers is going to equal to either, it can be 9,216 or 254,016. Those two numbers, you actually just plug those in, then indeed you're going to get something of the natural number. Well, you will get a natural number, in other words, for these are also natural numbers as well. So there we have it. And yeah, that's pretty cool if you ask me.